Welcome to the second video in the series of videos on electromagnetism. In this demonstration, we're going to show you the electric field lines of a bar magnet and a solenoid and how they look same. So here is your bar magnet, and we don't know which one is north or which one is south, but we can easily find that out using a compass. So as you can see, the tail of this compass is the south, so this side should be the north of the magnet, and this side should be your south of the magnet. And once you have the north and south, let's see how the compass traces around how the needle moves around the compass, around the magnet. Wow, so that's like a loop. You saw that that's like a loop, so we draw the loop because the magnetic field lines is a path that is taken by your compass. So here we draw our magnet, and the arrow head was showing like that, so the direction that we show is like this. So keeping back your magnet here, you have, now let's draw the bottom part. Let's see what path it traces. It traces the same path, which is a loop. So here also let's draw a loop. And if you see here, when I go straight, it goes straight. So this goes straight. And as you see here, the needle is going a little sideward. So basically it's a wide loop. It's trying to do a wide loop. And similarly, if you try here, you have the needle going in that direction. So here, let's do this loop. And here, if you see, the arrow is moving towards the magnet. So that's a path that we will trace. And similarly, you can see the path traced here is like that. And here the path traced is straight. So there you go. So this is a magnetic field line of your bar magnet, where this is your north pole and this is your south pole. Now next you can draw many loops which are symmetric, because that's, you can be pretty sure that the compass will take that path. I mean, the needle will kind of show that direction. You can check it out. It's more or less it's correct. So it traces that path, right? Let's look at the magnetic field lines through a solenoid. A solenoid is a coiled, you have a conductor which is coiled around a cylindrical surface, as you can see this, and current passes from one end to the other through the coil, and we call this a solenoid. And once the current is passing through, let's see what effect is there any magnetic field through this with our compass. And you can see the magnetic field lines are tracing pretty much the same way as was traced by the magnet, by a bar magnet, right? So you can see that the compass is moving in, and if you would take it straight, it would go in that way, and if you take it this side, yeah, it should move the other way. And let's see the front, what happens if you move it ahead. You see it moving out like that, and here as well. Here it should move to the left. Maybe there is some problem with the pivot. All right. So now, what happens when we change the direction of the current? So you can see. Remember that the head was pointing outward, right? So now let's try changing the direction of the current. So now you see that the head is pointing inward, and you will see that it follows the same loop, right? It follows the same loop as it did before, right? So here you go. So let's see what's happening here. So here is our solenoid. And these are the coils. Or we can take this out. These are the two ends of the coil. And as a current is passing here like that, current is passing here like that, what we see that there is a magnetic field. There's a magnetic field line, just like before. There you go. And the arrow is the direction of this field is given by given like that. It's the way you find that is you curl your finger in the direction of the current, and this is your right hand, and this is your thumb. So if you curl in the direction of the current, then your thumb gives you the direction of the magnetic field. So it's very important that you use the right hand for this. So there you go. So this is a magnetic field of a solenoid, and if you reverse this current, which is if you would now instead if you pass a current like this, then the magnetic field line would go in this direction. So the loops would be exactly the opposite of what you saw in the previous case. So in short, your solenoid behaves exactly like a bar magnet, and in fact your bar magnets are made using solenoids, which you'll see in the next videos. And changing the direction of current in the solenoid changes the direction of the magnetic field. So change in I changes D direction, change in I direction. So that's one property of solenoid. Solenoid magnetism can be switched on and off. So that's the second thing. And you can control the strength, right? You can control the strength by altering current. So one thing I can basically do that by changing the regulator setting. So I can increase the current. You can see the bulb is now glowing brighter, and I can see that the magnetic field strength would have slightly increased. So the magnetic field strength would have increased. Or the other way to change your strength of this solenoid would be to increase the number of coils. So you can increase strength by altering current, which is basically increasing current. That is one. Or you can increase the number of coils. So that's how you can strengthen the magnetic field. Strengthen the magnetic field. I hope you enjoyed this video. See you in the next one.